Good evening, everyone. I hate to interrupt, everyone is having such a good time, but we have a great presentation. The best part of my job is speaking to the most talented people in technology. By the way, I'm not sure that you know, DevX is not actually an event company. We're doing staffing and recruiting for technology. DevX started from out of my passion of technology. I've been a software developer. I've been a CTO, and I saw that there are no technical recruiters in the firm market, and a developer's job is very different than an accountant. We all know that it's different challenges and different problems, and that's how DevX came to be. So if you know anyone that is hiring, or you know anyone that is looking for a job, send me a message, let me know, and I would love to help. So one of the people that I met throughout the years, it was Ben Schwartz, and we right away hit it off, and he graciously agreed to come speak by the DevX meetup. He has a lot of interesting stuff to say, and the topic he chose for tonight is a controversial one, or maybe not so controversial. We'll find out. It's meant to be a conversation, so if anyone wants to interrupt or has something to say, feel free. And there is also going to be a Q&A at the end.
Okay, in the next 30 minutes or so, I want to change how you think about tech debt. Not to excuse sloppiness, but to replace a vague, emotional conversation with a practical one you can use with developers, leads, and managers. And I'm going to start with a sentence that you're not supposed to say out loud to a room full of developers. Tech debt is good. Not all of it, not the kind that's quietly rotting your systems, but the belief that tech debt is inherently bad is one of the most expensive misunderstandings in software. If you have zero tech debt, you are probably undershipping, or you're accumulating it invisibly, or you're calling it something else. Quick poll. Who here has been told we need to eliminate tech debt in the last year? Now, keep those hands up if the same people demanded that you ship faster. Exactly. Tech debt becomes the moral argument, clean versus dirty, good engineers versus bad engineers. And that framing is why teams drown. Let's fix that framing. Quick context so you know where this is coming from.
Could you just define tech debt, what you're talking about?
You'll hear it in the next 3 slides what tech debt is. But typically, technical debt is something that is used as a detriment to your system. Old code typically is how it's referred to. I'm going to change that definition a little bit. So quick context, you know where this is coming from. I'm currently the CTO at Qubitekk Cabinetry. I've been in CTO roles now for about 15 years. Started full stack development about 30 years ago. Everything I'm sharing now comes from decisions I've made and the consequences I've had to own. This isn't theory, it's scar tissue. So let's talk about, so here's the reframe that changed how I think about tech debt. I think about it like financial debt. Leverage is what you get immediately. Speed, learning, progress, getting to market, getting out of a hole. Interest is what you pay over time. Slower changes, more risk, more outages, more confusion, more work. So the question isn't, do we have debt? The question is, what leverage are we buying and what interest rate are we signing up for? We talk about eliminating tech debt like it's a realistic end state. But zero debt isn't the goal. Control is the goal. Because the world changes. Requirements change, constraints change, people change, scale changes, the right design changes. Even rewrites don't eliminate debt. They refinance it into a new shape. So the goal is not purity. The goal is controlling what you owe, why you owe it, what it's costing you, and what would make you pay it down. If debt is inevitable, the real skill is knowing which debt helps you win and which debt quietly destroys throughput. So there are 2 kinds of debt. I separate into 2 buckets. Good debt is explicit. It's time-boxed. It has a payoff. It has a trigger that tells you when to repay it. Toxic debt is hidden. It compounds. Nobody owns it. It surprises you at the worst possible time. I'll give you an example of each. First, the good kind. When the workflow is evolving, code is the worst place to freeze it. You will hard code today's confusion into tomorrow's systems. Here's the trap. We tell ourselves we're building the real solution, but what we're actually doing is locking down assumptions that haven't earned the right to be permanent yet. The team ships something that looks official, and suddenly every workaround becomes a new policy. In early stages, the highest value work is not perfect automation, it's discovering the stable path. Where do requests actually enter? Where do they stall? Which exceptions are real and which are just noise? What does done mean to the business? So good tech debt is a bridge. It's a deliberately temporary layer that keeps the business moving while you learn. It creates visibility, forces consistency, and turns chaos into data. And you only earn the right to automate once patterns repeat and the edge cases stop changing every week. That's why the key question is not, can we build it? It's, is the workflow stable enough that building it won't require a rewrite in 60 days? We were under pressure to automate parts of a production scheduling system, but the truth was the workflow was still evolving. Edge cases were showing up constantly, exceptions, special handling, last-minute changes. If we had rushed to build a full scheduling system immediately, we would have hard-coded the wrong process. We would have automated confusion. So we took on intentional tech debt. We built a manual bridge in Google Sheets. The sheet tracked the production schedule as a single source of truth. It wasn't glamorous. It definitely wasn't the final architecture. But it gave the business immediate visibility. It forced consistency around what was scheduled, what changed, and what was blocked. And here's the most important part. It let us observe the real process at real volume before we automated it. We named that debt up front. We documented what we were not building yet, and we set a repayment trigger. Once our proposed scheduling system matched about 90% of what the Google Sheet was doing in practice, that was our signal that the process was stable enough and volume justified automating the core. That bridge brought speed now, clarity later, and it avoided a rewrite. Good debt has a payoff and a trigger. So what makes debt good? If you want to take on debt intentionally, you need 4 rules. 1, you got to name it. If it isn't written down, it is not managed. 2, time box it. Debt without a time boundary turns into tradition. 3, tie it to a payoff. What leverage are you buying? Speed to market? Are you learning something? Survival of the company? Is it revenue? 4th, define a trigger to repay it. This is the part that most teams skip. If you cannot state the trigger, it isn't good debt. It's just unpriced risk. A trigger can be stability or volume, revenue, a milestone, or a known event, but it has to be something real. Now let's talk about interest rates, because not all debt costs the same. High interest debt is the stuff that taxes every future change or creates extra risk. Data ambiguity, security gaps, brittle deployments, inconsistent definitions. Low interest debt are things like style issues, minor duplication, refactors that don't unlock anything. One of the most common failure patterns I see, teams spend months paying down low interest debt because it's visible and annoying, while high interest debt quietly compounds and then explodes. Let's make this real. Turn to the person next to you. Name one piece of tech debt in your world with a high interest rate. Not the annoying one, the one that taxes every change or creates real risk. Call them out. Let me hear some. Good. What else? Who else has tech debt? Can't be that none of you have tech debt. Good. Anyone else? Anyone else brave enough to talk about their tech debt? Console logs, that's a good one.
Black box, untyped Redis saves and reads.
Good. Those are all very good, actually. Notice how none of those are code style. That's the point. Sometimes the debt that kills you is not code at all. In a homegrown ERP, the most expensive tech debt we had wasn't messy code. It was reporting that nobody trusted. The reoccurring fight was sales versus production. But the real issue was simpler. People didn't know what the reports were actually showing. One group thought sales meant booked orders. Another thought sales meant units produced. Timing assumptions made it even worse. So the same report produced different interpretations depending on who was looking at it. The ambiguity had a brutal interest rate. Meetings turned into debates instead of decisions. People created shadow spreadsheets. Engineering got dragged in constantly to explain numbers, and every explanation made someone else less confident. So we treated it like debt instead of mystery. We clarified definitions in plain language. We assigned ownership for each metric. And we retired duplicate reports so there was one canonical answer per question. The win wasn't prettier reporting. The win was trust, faster decisions, and engineering was no longer the referee. The highest interest debt was ambiguity, not code. Now, how do you manage this intentionally without it becoming theater? Let's talk about the framework. Here's the simplest framework that I've found that actually survives real life. Classify, price, pay, track. If you do this consistently, the entire conversation changes. It stops being, we should clean this up, and becomes, this debt costs us X at an interest rate of Y, and we're choosing to carry it until trigger Z. First, classify. Most teams, again, only talk about code debt. That's not where the biggest damage always is. I use 5 categories. Product debt, missing capabilities or UX shortcuts. Code debt, design shortcuts, coupling, duplication. Data debt, unclear definitions, poor schemas, missing lineage. Ops debt, manual deployments, fragile environments, no runbooks. People debt, knowledge silos, undocumented systems, onboarding gaps. If you're a manager in this room, this is important. A lot of what feels like engineering is slow is actually ops, data, and people debt. Once you classify it, you need to price it. Debt becomes manageable when it becomes legible. Even a rough estimate works. There are 3 ways that I like to price it. Time tax. How many hours per week are wasted because of this? Change tax. How much slower does each feature become to deploy? Risk tax. Probability times impact, like outages, security incidents, bad decisions. If 3 engineers lose 2 hours a week to a brittle process, that's 6 hours a week. Over a quarter, that's 70 hours. That's multiple engineering weeks of capacity. That's not cleanup, that's throughput. The number is why pricing changes the conversation with leadership. Once debt has a price, it stops being a debate and becomes a decision. Third is to track it. Debt must live in the same place as feature work. If debt is not in your system of record, it doesn't exist. And if it doesn't exist, it compounds. At minimum, a debt item should have a category, an interest rate, high, medium, or low, an owner, a trigger to repay that debt, and it should be linked to the feature that incurred it. Next is to pay it down strategically. Three repayment strategies that I like to use. Refactor as you go. Attach debt pay down to adjacent feature of work. Do small debt sprints, time-boxed, focused, not endless. Or quarterly initiatives, when it's something that needs cross-team coordination. The biggest mistake is treating debt as a separate, endless cleanup program. Pay down debt in the path of value and prioritize by interest rate. Finally, cadence. This is what makes it real. Weekly, you should review your top debt items by interest rate. Not 100 items, just the top ones. Monthly, pay down 1 or 2 high interest items that are taxing every change. Quarterly, retire an entire debt class. For example, this quarter we remove manual deploys, or this quarter we fix definition drift in reporting. So here's the close. Stop asking how do we eliminate tech debt. The question sounds responsible, but it usually leads to 2 bad outcomes. Either it becomes a vague guilt trip with no plan, or it turns into an endless cleanup campaign that competes with shipping and never actually finishes. The team stays stuck arguing about priorities instead of making explicit trade-offs. Start asking, what debt are we choosing? What is the interest rate? And what is the trigger to repay? Because that question forces clarity. It forces you to name what you're buying with that debt. It forces you to acknowledge what you're paying for it every week. And it forces you to decide what would change your mind. And when you can answer it, tech debt stops being a complaint and becomes a strategy. Developers stop feeling like they're losing a purity contest. Leads stop being trapped between quality and deadlines. Managers stop hearing engineering wants to refactor and start hearing this is a throughput and risk decision with a price tag. So if you take one thing from this talk, take this. Treat tech debt like a portfolio. Take it intentionally. Price the interest. Put triggers on the biggest items. Then pay down the high interest debt that's quietly stealing your ability to move fast. That's how you ship with leverage today without handing tomorrow a system that can't change. Thank you, guys. I'm happy to take questions if anybody has any questions.
How do you document like what software would you use or the Google Sheets just now?
Good. So the question was, how do you document tech debt? So I find that it depends on how you're documenting the rest of your requirements and the rest of what you're working with, right? So if you keep your requirements or your sprints or however you're doing your technical work in Google Sheets, then Google Sheets is fine. If you use Jira or ClickUp or something of that nature, that's where it should be. Treat it like a feature. Treat it like something that needs to be addressed. Otherwise, you lose track of it.
Exactly. Whatever platform you use to communicate, make it a different platform. So if you're using Teams to communicate, do it on Loop. Do it on a different subcomponent, and that's just miyuchat or just set for that particular thing. Because there's always going to be a list of stuff that you can't do, and you prioritize your tech debt on that.
How do you feel that Cursor is going to, and similar tools are going to change just how bad tech debt is going to get?
That's a great question. So Cursor and other AI tools and things that are code generators, vibe coding, I don't know if it's going to, I don't think it's going to generate any more tech debt than exists today. It's just going to make it easier to ignore that tech debt. So you create your code via AI, and then you just assume that it's working and leave it there, and nobody understands what the prompts were, or how you created this code, or really what the code's doing because of however their naming conventions are set up, or however you set up the code for that thing. Especially also from a knowledge gap perspective, right? That's the biggest issue that I find is it's more about knowledge gaps than anything else. Things in people's heads, not documenting, to me is the biggest form of tech debt.
You had in one of your slides schema lineage. What does that mean?
So in terms of what is the history of that schema and where does it live across the stack?
You also included there like there's a problem in the code base I'm working on where you have these objects in Redis and there's not necessarily a clear path of where they get initialized and what the hell is happening in between here and there. It's causing a lot of bugs actually.
That's it on the head. That's exactly it. It's tech or something in your product that is causing a problem that either you don't know what it is because somebody built it 5 years ago and nobody documented it, nobody understands it. And the trick is two things. There's two things that can solve that kind of tech debt, right? It's either some sort of rewrite or documentation. Once you document it, once you get an understanding of what's happening from that data layer or the way that the data is moving and it's documented, now it can be passed around. Now a new developer can read that doc or whoever's dealing with this information knows what it is and it's no longer a liability.
Thank you.
Sure.
A lot of what you mentioned, there's like two different parts. There's the development tech stack, and then there's a lot of, it seems like missing business analysts, missing change
Sure.
management, missing a lot of that, which I found a lot of business owners think, I'll just get a developer and tell them what I need, and out will come the program, but it doesn't work like that.
It's a great point. And I think my personal belief is a lot of tech debt does not come from technical people. It comes from the non-technical people, whether it's business owners or I don't want to say BA, QA kind of stuff, because they actually have a better handle on what's from a knowledge perspective, from a tech debt perspective. But it's a lot of times it's business owners who don't document the process or create a new policy for whatever they're trying to produce without any kind of reason or backstory around it, and then it just gets lost as, oh, we hard coded it this way because that's what Joel told us to do, and then you're left. It's always Joel.
A little more real controversial question. I mean, it's the elephant in the room with a lot of probably developers is AI in regards to tech debt, but in regards to the entire spectrum. Will AI eliminate tech debt? Will you get to a point where all these things that you mentioned, where from the business, will the AI, LLM, or process take over that job where you'll have one master telling you, hey, this is your inefficiency in your way of doing things, and they might even do your job where you'll have to oversee and check. There will be more of a managerial perspective on it versus the actual nuts and bolts of it. Do you think that's happening? Is that coming?
That's a good question. So we started talking about AI a little bit over here about in terms of code generation, but you've blown it up a little bit bigger. I think AI can definitely help in solving what I'll call code-based tech debt, right? It could definitely, and I've done this with a couple different AIs, you give it a huge code base and have it produce documentation for you. And I find that definitely helps. It doesn't get you all the way there. It may get you 80% of the way there, but it definitely can solve some of the unknown, the hidden things in code. But the ops part of tech debt,
Why not? That's what I'm asking. Because if I can ask Gemini a certain question, that basically is the operation of a certain, let's say, coffee machine, let's say, is soft water going to? They'll have all those factors that are in this
right.
schema of business to product. They'll break that down because why is that not coming next?
So for something that it knows, yeah, for sure, it can do that. The bigger problem is,
And the module of breaking down the process. If you can learn chess, you can learn this. It's just a matter of time.
you have to feed it. So if you're in a company, let's say the company that I'm at now, at Cubitech, that has a 13-year-old code base and has certain SOPs and processes that aren't documented and policies that were written because this is what the code did, AI is never going to be able to help you with that because it doesn't know.
No, it can read.
It can't read Joel's mind, right? Joel, the tech that in that case is CEO.
But I will say why,
Yeah.
why it can't. Because it will figure out how X got to Z, basically, and then we just work its way backward.
I don't think it can. I don't think it can. It can tell you what Z is.
It doesn't know what's going on the shop floor. It doesn't know what sales
Right.
are doing. It might know your coffee machine, but the coffee machine is there. But it doesn't know what's going on.
Because why? Because it doesn't know it.
Because it doesn't know. It doesn't know what's in the CEO's head.
He said it doesn't know what's going on the shop floor. It's very simple. What is that information?
But that plus sales plus all the different machines, like, yeah, if you get AI to sit over the company for a year, whatever, it's not you. It just needs to monitor your company.
It has to have enough of the data. In my opinion, it has to have enough. It doesn't. It's not going to have enough data to get to that point. Maybe. Listen, AI can change in the next year, and you can have an AI that's sitting, humanoid AI that's walking around your tech floor, your production floor, and it can figure that
What's
out.
coming next, by the way?
Yeah.
So you know.
Any other questions? Thank you, everybody. I really appreciate it. Thanks.